decreasing sequence in R which is bounded below is convergent. It is same as we proved for monotonic increasing. So I assume that you have done. I'll not do. Yes. Now let us see some standard sequences. Convergence of some standard sequences. Okay. The first came in this is 1 upon 1 plus NE, and 1 upon 1 plus NE, you already know about that, correct? Just 1 second. Limit intending to infinity 1 upon 1 plus NA, and that is equal to 0, correct? That is convergence. The first one is this, and can you prove this? Can you prove this? 1 upon 1 plus NA goes to 0. And if you come for proving, then what should you do? Let me quickly do the proof, correct? uh, for given epsilon positive, to find n naught belongs to natural number such that mod of 1 upon 1 plus ne minus 0, that should be less than epsilon, correct? For all n greater than equal to n naught. So this is what I want to uh, get, correct? Now let us see. Let us put some space here and start consider mod of 1 upon 1 plus ne minus 0. That was the trick, to keep some space here and try to see. Can I say something about this? This is 1 upon 1 plus na, and this is always less than 1 upon na. Do you agree? Is that true? Yeah. Okay. So now can I relate with 1 upon na something? Can I prove this is less than epsilon? Something like that. Can I do that? I just try to remember uh, what I want to do. I want to prove this is less than epsilon. Perfect. That means 1 upon Na is less than epsilon. This is what I want to prove. Correct? So, can I use Archimedean property? Epsilon positive. So, 1 upon epsilon into E, that is also positive. Do you agree? Can I use Archimedean property on 1 upon epsilon A? By Archimedean property. By Archimedean property, there exists n naught belongs to natural number such that 1 upon epsilon E, that is less than n naught. Do you agree? Yes, what do you mean by that? Can I take n naught here and epsilon E there? That means what? 1 upon n naught, n naught E, that is less than epsilon. Okay, so can you complete this now? 1 upon Na, is that less than 1 upon n naught E? Why? Because we know one thing, that is n is greater than equal to n naught, so 1 upon n is less than equal to 1 upon n naught. I am just multiplying E, so that is not an issue, and 1 upon n naught, and this part is less than epsilon by Archimedean property, which implies 1 upon 1 plus Na goes to 0. Hence proved. Look at the proof once again quickly. See if you have any doubt. This part is we'll be writing later on, after completing this. This part is later on. So keep some space in between whenever you are doing convergence part. Keep some space after writing the definition. Give some space. Yes. Yeah. So that was the first one. Let us do the second standard sequence. And that was easy to see, because 1 upon in the denominator it is n का term अगर आया तो that is going to be 0. Let's do the second one. If 0 is less than b is less than 1, then limit n tending to infinity b raised to n is equal to 0. This is what we want to prove. First of all, do you observe, if your b is between 0 and 1, then b raised to n will be 0. You can take some values. Suppose if you take b is equal to say 1 by 2, that is zero point 0.5. Zero point 0.5 is lying in between. Then what is zero point 0.5 square, zero point 0.5 cube? Do you see they are going towards 0? Do you observe that? Yeah, good. So now let us see. Let us see about that. How to prove this. There are two methods to prove. I'll give one. See, 0 is less than b is less than 1. So what can you say about 1 upon b? That will be greater than 1. Do you see? Look at this thing. If I take 1 by b, then it will be greater than 1. So can I write 1 by b as 1 plus something, some e positive? Because it is greater than 1. Once e 1 by b is greater than 1, so can I write 1 by b as 1 plus something, and that something is positive number? Can I do that? Okay. Yes. What else? What should I do now? Is that clear to you? Did you understand what did I do? I wrote b is less than 1, so 1 upon b is greater than 1. So I'm writing 1 upon b is equal to 1 plus something, because it was greater than 1. So I'm just writing 1 plus something, and it was strictly greater than 1. So that's why. So this is non-zero also. It is strictly greater than. Okay. So can I get the value of b? B is equal to 1 upon 1 plus a. Yes. And what is b raised to n? 1 upon 1 plus e raised to n. So this is what I want to prove. I want to prove the b raised to n goes to 0. That means this guy goes to 0. Correct? And do you see ये binomial expansion के जैसा नहीं दिख रहा है तुमको? So can I use something? 1 plus e raised to n. What can I write? That is equal to 1 plus ne plus n into n minus 1 by 2a square, and so on. Correct? But I don't want all the term. I want just this term. How can you relate? That means 1 plus e raised to n, that is greater than equal to 1 plus na. Can I do that? Because I'm just taking first part, so that will be less than equal to the original sum. Yeah, correct. And this is again greater than na, I think. This is again greater than na. But I don't need it now. Let us keep it like this. So what about 1 upon 1 plus na? So if I go for 1 upon 1 plus e raised to n, then what will be the relation? It will be less than, equal to 1 upon 1 plus na. Do you agree? Okay, nice. Now one more observation. Do you see this guy goes to 0 as per the previous proof? Yes. And can I write like this? 1 upon 1 plus e raised to n, that is lying between 1 upon 1 plus na, and that is between 0. Can I say like this? Even I just want to relate this with your sandwich theorem. After that, you can use your usual epsilon delta, that is also acceptable. That means if you take mod of this, then mod will be less than equal to 1 upon 1 plus na, and that is less than 1 upon na, and that's it. by comparison, that is also okay, but I just wanted to relate with your sandwich theorem. So it is squeezed between two people. This guy is going to 0 and this is a 0 sequence. Correct? So what is your conclusion? And this is the bn, this is b raised to n, limit n tending to infinity, b raised to n equal to 0. That is what I wanted to prove. Remember, I just now told you that if you don't want to use sandwich theorem, still you can prove this. What will you do? You want to prove this guy goes to 0, so you'll consider that. Consider 1 upon 1 plus e raised to n minus 0, and then you'll later on you'll write this is less than equal to 1 upon 1 plus na, and later on you will write this is 1 upon na, and then wo epsilon wala part, how did you get na n naught? So this is less than equal to 1 upon n naught e, and that less than epsilon, that is also acceptable. अगर बीच में तुमको आर्किमिडियन प्रॉपर्टी यूज करनी है, by Archimedean property, what will you do? 1 upon epsilon a, that is less than n naught. So here you can relate. So whatever you want to do, in the both the cases you'll be getting limit n tending to infinity b raised to n is equal to 0. Yes. Yeah, that was the second one. That is when your b is between 0 and 1, then this goes to 0. Let us see the third one. When b is between this minus 1 to 1, then also limit n tending to infinity b raised to n is equal to. Can you do that quickly? Minus 1 to 1, you, if you don't like this, you may write it mod of b is less than 1. Both are same, I hope you agree. Mod b is less than 1 is same as minus b, and like that. Yes? Do you agree? Abhi we just now proved something. Mod b less than 1 means what? Minus 1 is less than b is less than 1, correct? So let us break it into two parts. Minus 1 is less than b is less than 0, and b is between 0 and 1, and b equal to 0. B equal to 0, then there is nothing to prove, and this part we have already proved. What about this one? How will you do that? If your b is negative, so what you should do? You should write it as minus 1 raised to n into a raised to n. Correct? Where e will be lying between 0 to 1. Do you agree what I am doing? I am writing this guy as this. Can I do that? Can I do that? Minus n नहीं आएगा ना, it will be just minus 1 into a raised to n, where a is between 0 to 1. Now we already know a raised to n goes to 0, so minus 1 is not an issue for me. It is just a constant, correct? That will also go to 0. Do you agree? Yeah. So there is nothing to prove much, but if you want to still write the proof, then you can do by taking three cases. Case 1, if your b is between this. Case 2, if b is 0. Case 3, if b is between this. Then if in this case you'll write b as minus 1 a raised to n, where a is between 0 to n, and you know that a raised to n goes to 0 if your a is between 0 to 1. So that's it. Minus 1 is not a problem for me. The third one is stronger one, better than the second one. Okay, let us see the fourth one. Let C belongs to R be any positive real number than limit n tending to infinity C raised to 1 by n, that is equal to 1. First of all, do you agree? Do you agree? C is any positive number. It need not be between 0 to 1. It may be anything, correct? what they are asking you, that c raised to 1 by n equal to, and if you remember, I already told you 1 upon infinity क्या होता है, that is 0. So if you put c raised to 1 upon infinity, so 1 upon infinity that will be 0, that means c raised to 0, तो आंसर must be 1. करेक्ट. सो ये अपने यूजुअल लिमिट जैसे हम लोग सॉल्व करते हैं उससे भी ये फॉलो होता है. करेक्ट. सो जस्ट वी नीड टू प्रूव नाउ. Yes, is that okay? Shall we start? Yeah. So we are given c as a positive real number. Uh, what about when c is 1? We need to take three cases here, I think. Yeah. Case 1 will be when c is, uh, let us c is equal to 1. If you take c is equal to 1, then there is nothing to prove. Do you agree? Then limit of n tending to infinity c raised to 1 by n, that is equal to 1. That is okay. Case 2 I should take when your c is between 0 to 1. Correct? Since they are saying c is just a positive real number, that means they are given as c as a greater than 0. That's it. Now greater than 0, I am breaking it to three part. The first I am taking c is 1. The second is c is between 0 to 1. How to do c is between 0 to 1? I had already given you a trick. When you are having c is between 0 to 1, what about 1 upon c? That is greater than 1. Yeah. Wait. I'll use this thing. I'll use this thing. Now see. Let us do case 2 as suppose c is greater than 1. Okay, I'm taking case 2 as this one. Case 3, I'll take c is between 0 to 1. Yeah, when my c is greater than 1, what about c raised to 1 by n? That is also greater than 1. Do you agree? Well, smallest value will be 1, and after that everybody 1 से बड़े ही रहेंगे वो लोग. Do you agree? C raised to 1 by n, that is greater than 1. Once it is greater than 1, can I write c raised to 1 by n, that is equal to 1 plus some a, where a is a positive number. Can I write like this? So what about c? C is now 1 plus a raised to n. And you know what is 1 plus a raised to n, correct? 1 plus n a plus n into n minus 1 by 2 a square and so on. Last term will be a raised to n. So can you relate this? Can you relate c and this term? Here I don't require this 1 because he will later on see I don't require that 1 here. Can I write like this? C is greater than NA. Can I write like this? From this expression, that is C is equal to 1 plus NA plus, if I'm taking just one part, one term, that is NA. So can I write that C is greater than NA? Yes? Okay. So if C is greater than NA, what about A? What can you say about A? A will be less than C by N. Do you agree? What about that imply A is less than C by N? Do you agree? Just check. Yes? Yeah. So you are having A is less than C by N, and what do you want to prove? You want to prove C raised to 1 by N. You want to prove C raised to 1 by N converges to 1, correct? This is what you want to prove. So consideration part क्या करना है अपने को? Consider C raised to 1 by N minus 1, correct? Consideration यही करते हैं ना जो हम लोग को proof करना है. You want to prove C raised to 1 by N goes to 1, so I'll consider C raised to 1 by N minus 1. And how can I relate with this? C raised to 1 by n minus 1 क्या आएगा? C raised to 1 by n minus 1, it will be a. Do you observe? 1 को वो साइड लिया तो it will be just a. That means it is giving me just a. Mod a actually. एंड वी नो समथिंग, ए के बारे में क्या पता है, एंड ए इज लेस देन सी बाय एन, करेक्ट. Can I use triangle inequality, or can I use sandwich theorem here also? Or if you don't want sandwich theorem, you can use the Archimedean property, c by n. So this is less than c by n naught, and that is less than epsilon. Correct. And what will you write in the Archimedean property? By Archimedean property, yes, epsilon is positive, so c by epsilon is also positive. So there exists n naught belongs to natural number such that c upon epsilon is less than n naught. This is what by Archimedean property you are having. Yes. Hello. Yeah. So that is c upon n naught. Do you understand? C raised to 1 by n minus 1, that is equal to mod a, and that is less than c by n, that is less than c by n naught, and that is less than epsilon. Yeah. So that means what? What did we prove? Limit n tending to infinity. This is equal to 1. Just go back to the proof and check whether everything is correct. In this case, we are taking c is greater than 1, and c raised to 1 by n is greater than 1, and so on. Then we started, it is greater than 1, so I'm writing it as 1 plus a, and later on c is greater than a. Okay. Now one case is still remaining. What is that? Case 3, and I already told you I'm going to use case 2 for that. What is case 3? My c is between 0 to 1, correct? So what about 1 upon c? That is greater than 1. Can I use by case 2? Can I use something? Limit n tending to infinity 1 upon c raised to 1 by n, that is equal to 1. Can I say? If this is greater than 1, so by case 2 हम लोगों ने क्या लिया था? If my number is greater than 1, then power 1 by 1 लिया, 1 by n लिया, then that will go to 1. So by case 2 I am doing that. What do you mean by that? That means limit n tending to infinity 1 upon c raised to 1 by n, that is 1. That means limit n tending to infinity c raised to 1 by n, that is also 1. Just cross multiply or whatever you say. So in this case also we got that c raised to 1 by n is equal to 1. So in all the three cases we are getting the same. C equal to 1 pe, there was nothing to prove since it will become a constant sequence, and case 2 is when c is greater than 1, and case 3 is when c is between 0 to 1. Correct? Yeah. This was the which third, fourth one. Now let us see one more, that is the last or fifth. Fifth one is limit n tending to infinity when you are having n raised to 1 by n, then also this is equal to 1. This is what you want to prove now. Limit n tending to infinity n raised to 1 by n, that is also 1. So how will you prove? Same, let us start. Since n is greater than 1, what about n raised to 1 by n? That will be also greater than 1. Correct? If it is greater than 1, so what I am going to write? As per the trick we are using all the time. As per the trick all the time, that means n raised to 1 by n will be 1 plus something. Something, but that something will depend on n. I hope that is clear to you. That something will depend on n. It is not depending, it is not a constant, it is not just e, it will depend on n, so I'm writing en just for make sure that it depends on n. That means let me take, suppose n equal to 1 liya, then if I take n equal to 1, then this guy is 0. If I put n equal to 2, then it is root 2. Root 2 is 1.414. Then e2 will be 0.414, like that. Correct. So for each n I am getting different, so I am just representing it by en. That's it. Where en is positive number there. Yeah. So what next? N raised to 1 by n hai. Taking nth power both the side, then you will be having n is equal to 1 plus en raised to n. And you know what next we are going to do? We are going to apply the binomial expansion on this. This is 1 plus n e n plus n into n minus 1 by 2 e n square, and so on. Correct? And yeah. So can I write like this? N is greater than 1 plus n into n minus 1 by 2 e n square. I'm taking these two terms. And you'll be surprised to see why I'm taking this and this only.